Hello everyone, welcome you to this session of YouTube. Today we are going to discuss 2018 question paper, the third session. Okay, yes, myself Clotilda Reshma is welcoming you for today's YouTube session. I am a maths educator in Unacademy. I take up CET classes, KCET, Karnataka CET in Unacademy. Also, I take up the comprehensive batch course and special classes in Unacademy, which platform reaches to thousands and thousands of students all over. Before I continue the session, I would request you all to please like, share and subscribe this channel, and don't forget to click on the bell icon. Please do follow me on Unacademy to get more super tricks, shortcuts to solve the problems easily and quickly in Unacademy. Yes. Now, this Karnataka CET 2021 comprehensive batch course. Here, this is live on Unacademy Plus. The complete syllabus is being covered. Tips and tricks are given by the top educators. Topic-wise practice questions are given. Full-length mock tests are given in this course. Okay, this month plan is valid till December 31st, that is till this month end. Okay, but don't forget to use my code ReshmaLobo17 to get extra 10% off on any of the plus course which you join under this Unacademy. Okay, yes. We have this best plans, as I can say, for Karnataka CET 2021 aspirants. There are different month plan, 12-month plan, 6-month plan and 1-month plan. Yes, so we have here the very important feature which I can say about this plus course is nothing but here the dedicated live doubt clearing session. Now through this session, the live doubt clearing session, we can interact directly. Okay, a student can interact with the educator and get cleared all their doubts. Okay, yes, but don't forget to use this code ReshmaLobo17. You will get extra shortcuts, super tricks to solve KCET in a quicker, shorter way. Okay, yes. So we have been solving the 2018 question paper and we are in the third session right now. We are solving the third session of 2018 question paper. Okay, so now this 2018 question paper, we have solved at about a few questions. So now we are going to for a third one, that is from 17th question. So we have already solved 16 questions in the two sessions. So we are going to solve the third set now, third set. Okay, so yes. So are we all ready for it? Yes. Okay. So let us move on to the first question of today. Yes, so also there are a free practice test for Karnataka CET which is already started. Yes, enroll for it, attempt it, and yes, so crack KCET together. Yes, so we will stay united to crack KCET in a quicker way. Yes, so we go to the first question of this session. Yes, look at this question. What is the question telling us? A is a set. Okay, so this is about the A is a set having 6 distinct elements. Okay, so in a set A, there are 6 elements that is being mentioned here. The number of distinct functions from A to A. So this question is from Relations and Functions chapter. The question asked to us is, you have to find out the distinct functions from A to A which are not a bijective function, which are not bijective. So for this, we need to have a shortcut. I will tell you a shortcut. Yes, so be prepared to listen here. Yes, so we have a shortcut. Now the shortcut goes like this. Suppose there are A and B set. Okay, and number of elements suppose in the set A is equal to m and number of elements in the set B is equal to n. Then number of functions, okay, just functions. So the number of functions possible, very important shortcut, you need to memorize this. So number of functions possible is n to the power m, that is number of elements in the set B, okay, the second set, to the power number of elements from the first set, n to the power m. Okay, so now we have here, okay, so that is about the function. So keep it aside. I will tell you how to clear this question. Next we will come to number of bijective functions. Okay, so number of bijective functions, from A to B, from A to B. Okay, so bijective means what? It has to be 1, 1, it has to be on 2. So this is equal to n factorial when that n and m are equal. Suppose by chance they are not equal, then the number of bijective functions will become 0. So now coming to this, so here coming to this question, in this question it is told the function is going from A to A. Okay, so the function is going from A to A, and A is having how many elements? A is having 6 elements. Here also A is having 6 elements. What you want? You want the distinct functions from A to A which are not bijective. Okay, so we want here the functions which are not bijective. How can I get this now? Can I say all the possible functions minus the functions which are bijective? Got it? Okay, so this is a negative question, right? So the functions are not bijective. Functions are not bijective means together all the functions. So that is number of functions, minus the functions which are bijective. Okay, so this is the positive one. Now, if we have, I have told you n of A, number of elements in the first set is m, number of elements in the second set is n, and number of functions is n to the power m. So what will happen here? What is the number of functions possible? It is 6 to the power 6. Minus, we want bijective functions now. Bijective functions, when n and m both are equal, then only n factorial. Now look at the number is 6, here also it is 6, so both n and m are equal. So what is a bijective function? It is 6 factorial. So this will give you the answer, the functions which is not bijective. So only thing you should know, how many number of functions are possible. Functions are possible and bijective functions also possible. Okay, so yes, so hope you have understood. So which option we are going to satisfy is the C option, which is satisfied. Okay, this is a 2018 question paper, Akash, 2018 question paper, the third session we are going to solve. Got it? Okay, yes. So we hope this is clear. This question is from relations and functions topic. Okay, this question tells us where the functions, all the functions we have to find out which is not bijective. Okay, yes. So if it is not bijective, what we have to do? First we have to find out all the functions minus which are bijective, and I have given you the shortcut. Okay, all the functions is the second number to the power the first number elements, and bijective will work only when n and m are equal, both the elements in the set are equal, otherwise bijective will become 0. So here we are having that C option, 6 to the power 6 minus 6 factorial. Hope the idea is clear? Yes, okay. Come on, we'll go to the next question. Let's see what the next question is telling us, the question number 18. So look at this question number 18. Let f be a function from R to R is defined by f of x is equal to 2x for x greater than 3, x square for x greater than 1, less than or equal to 3, 3x for x less than or equal to 1. Then f of minus 1 plus f of 2 plus f of 4 is. Okay, so what we have to do again, this is from the first PUC topic. Okay, relations and functions, first PUC topic. Okay, the first PUC topic. Now what is asked? We want to know the answer of the value of f of minus 1 plus f of 2 plus f of 4. Now search where is minus 1. So the first line is telling us x is going beyond 3, greater than 3. Second line is telling us greater than 1, less than or equal to 3. Third line is telling us less than or equal to 1. So f of minus 1, f of minus 1 means it has to be less than 1. So I am looking at the third line. So what it should be, what is f of x telling you? Write 1, 3. Okay, so I am writing 1, 3. And then f of x is telling put that x what is inside the bracket. So it is minus 1 plus f of 2. Where is 2 now? 2 is present here in the second line. It is coming under greater than 1, less than or equal to 3. So what is f of x telling? Write that x which is inside the bracket and put a square on top. So what I should write? Write this 2 and then put a square on top. Plus f of 4. Where is 4 now coming in the first line? Okay, 4 is coming in the first line. Okay, yes. So that is x greater than 3. So therefore what is f of x telling us? Write 1, 2 and put whatever is inside the bracket. So that is 4 now. So I am done with this. I am getting the answer. So this is minus 3. 3 into minus 1 is minus 3 plus 2 square is 4 plus 8. So therefore yes, we've got the answer. It is equal to 9 and that is my A option. Got it? Hope you have understood this. Very simple it is. Yes. Okay. Yes. Going to the next question. Next question. Yes. So we have this question from inverse trigonometric function. Okay. So if you know the properties of inverse trigonometric function, all the problems are very, very easy. Okay. So what is it now? If sine inverse x plus cos inverse y is equal to 2 pi by 5, then cos inverse x plus sine inverse y is equal to how much is being asked. Okay, so let us try this answer. So what is given to us? They have given sine inverse x plus cos inverse y. This is equal to 2 pi by 5. But I know one property in inverse trigonometry function, sine inverse x plus cos inverse x. What is this equal to? This is equal to pi by 2. So in place of sine inverse x, can I write as pi by 2 minus cos inverse x? Yes, possible, no? So what I will do, in place of sine inverse x, I will write pi by 2 minus cos inverse x. Okay, plus in place of cos inverse y, what I can write? Can I write this as pi by 2 minus sine inverse y? Same property. Yes, this is given to me equal to 2 pi by 5. Now, how much is pi by 2 plus pi by 2? 90 plus 90, 180, that is pi. Okay, so what I will do, I will shift this pi by 2 plus pi by 2, I will write pi minus 2 pi by 5, I will bring this side. Okay, so 2 pi by 5. And which I have here, minus cos inverse x minus sine inverse y, I will shift it to the right side. So therefore I will be getting cos inverse x plus sine inverse y. So look, have a look at the question. In the question, they have asked us that only. See, look at this. Cos inverse x plus sine inverse y, and I have reached this. So just I have to simplify this. So just simplify, LCM we have to take, isn't it? So therefore this will become 5 pi minus 2 pi, and that is equal to 3 pi by 5. So therefore we have cos inverse x plus sine inverse y. That is nothing but 3 pi by 5, and which option does it satisfy is our B option, which satisfies. Yes. Hello, Nagavini. Yes. So this is inverse trigonometric functions. So we are into 2018 question paper, the third session. Yes. So hope this is clear. So we got this answer 3 pi by 5, the B option. Clear? Yes. Clear. Okay. So coming to the next question of today. The next question, question number 20. Look at this question now. The value of the expression tan of 1 by 2 of cos inverse 2 by root 5. Once again, this is inverse trigonometric functions as well as trigonometry. Both are together. Okay. So it is inverse trigonometric functions as well as trigonometric functions together. Now let us see what idea should come to my mind here. Okay, now the idea coming to my mind whenever you get such a question is, go innermost core, we say, no, go to the innermost core. Okay, so here we have tan of half cos inverse 2 by root 5. So what idea should come to my mind? Go innermost. That doesn't look that easy, no? So it is little uneasy, so I will give that as some, I will take substitution. Let me take that as some theta. Okay, so let cos inverse, let us see how does it change now. Let cos inverse 2 by root 5, this is equal to theta. So from this, what is cos theta then? Yes, so what is this cos theta? Cos theta is 2 by root 5, and we know so katoa ka, this is cos is adjacent by hypotenuse. So just let me find out here. So this is theta, so adjacent is 2 and hypotenuse is 5. So what is this opposite side then? It will become 1. 5 root 5 the whole square, 5 minus 4, which is equal to 1. Okay, so what is sine theta from this? Find out and keep it ready. What is sine theta? Opposite side by, so cut over, right? So opposite by hypotenuse. So it is opposite is 1 and hypotenuse is root 5. Okay, so now we have reached here tan of 1 by 2. What we have taken this? Theta. So isn't this becoming tan of theta by 2? So we have got that as now tan of theta by 2. Now tan I can write as sine by cos. So I can write this as sine theta by 2 by cos theta by 2. Okay. Now what I do is, look at this magic now. I multiply by 2 cos theta by 2 throughout. Okay. That is for the numerator also, for the denominator also. Let's see what will happen. Okay, so therefore sine theta by 2 by cos theta by 2 as it is. What I have to do is, I multiply by 2 cos theta by 2. Here also I multiply by 2 cos theta by 2. Okay, now see how beautifully it has changed. So what will happen? Who is 2 sine theta by 2 cos theta by 2? Tell me quickly. Who is 2 sine theta by 2 cos theta by 2? It is sine theta. So sine theta by, who is now here? What will happen? 2, this is nothing but 2 cos square theta by 2. So 2 cos square theta by 2 is whose formula? It is 1 plus cos theta's formula. And I am done. So therefore, who is sine theta? We got value 1 by root 5. Okay, and here we have 1 plus 2 by root 5. So therefore, this will become 1 by root 5 divided by, here it is root 5 LCM, root 5 plus 2. So root 5 gets cancelled. You have 1 by root 5 plus 2. But look at the answer, I don't have that. Yes, now it is becoming very easy, isn't it? So now so what comes to my mind? Rationalize it quickly. Root of 5 minus 2 by root 5 minus 2. So therefore this is root 5 minus 2 by a plus b. A minus b is a square minus b square, that is 1. So which answer is satisfying? Root 5 minus 2. Once again the B option is going to satisfy. Okay, see how beautifully the question which was looking little uneasy has changed to an easy option, that is root 5 minus 2. Okay, yes. So hope it is clear. Yes, so we go to the next question. Is this understood? Clear. Okay, so going to the next one. Look at this, question number 21. So question number 21 tells us a is 2 minus 2 minus 2, 2, and a to the power n is equal to 2 to the power k into a. I have to find what is the value of k. Okay, so I will do some ideas here. So this is from the matrices question. Okay, so what we will do here is just observe. A is given 2 minus 2 minus 2, 2. Let me just find who is a square. A square is nothing but a into a, isn't it? So let me keep this ready. So it is 2 minus 2 minus 2, 2 into 2 minus 2 minus 2, 2. So what will I get here? Answer, this is equal to 2 2s are 4. So we hope we know the multiplication. 2 2s are 4 plus minus 2 into minus 2 again 4. So 4 plus 4 you are getting 8. Next, minus 4 is minus 8. Next we have minus 4 is minus 8. Then 4 plus 4, it is equal to 8. Okay, so this I can write as, I can take out 4 because I want in terms of a, no? So it is, I can write this as 2 square. If I take out 4, I am getting 2 minus 2 minus 2, 2. So therefore a square, so what you have arrived here is a square is equal to 2 square into a. So I have to tally this one. I have to tally this one. Okay, so what I do is I check the options. So the options here is 2 to the power n minus 1. This is equal to k. Okay, so this is equal to k, the first option. Second option, n plus 1 is equal to k. Third option, n minus 1 is equal to k. Fourth option, 2 into n minus 1 is equal to k. Okay, so now observe, we have the condition a to the power n is equal to 2 to the power k into a. So what will happen if I put n is equal to 1? Just let us check whether it is satisfying our answer. So a to the power n is equal to 1, I should have a is equal to 2 to the power k into a. So here you are getting 2 to the power 1 minus 1, so therefore that is equal to a. Okay, so here you are getting here a is equal to 2 to the power n minus 1. That is not possible. Okay, so here first option gone. Second option, you are getting a to the power 1. Second option, a to the power 1 is equal to 2 to the power n plus 1 into a. That is also not possible if you put here n is equal to 1. Okay, not possible. Going to third option, so you are getting here a to the power 1 is equal to 2 to the power n minus 1 into a. This is satisfying. Also look at the next option, a to the power 1 is equal to 2 to the power n minus 1 into a is also satisfying. So first two options I will delete, the second two I have to make a choice. So for that what we will do, go for n is equal to 2. Look at here, now this should be my answer. Which option is giving you that answer? Which option is giving you that answer? So look at for n is equal to 2 over here. So you are getting a square is equal to 2 to the power n minus 1 into a. That is, you are getting a square. A square you should get what? 2 square into a. But here you are getting, if n is equal to 2, you are getting 2 into a. This is not possible. So here a square is equal to, what will happen? 2 to the power, who is k now? 2 into n minus 1 into a. Check this whether this is satisfying. A to the power 2 is equal to 2n. It is 2 to the power, n is now 2. So 2 minus 1 is 1. So 2 square into a. Is this tallying with what you have kept ready for a square? Because just with a we are not able to find out. So a square, when I found this answer, I got that the fourth option is tallying my answer. So therefore it is option D. Okay, so this is what you need to do here. Quickly we can do that. Okay, clear. So going to the next question, question number 22. Okay, this is a simple question. Once again, a question from matrix multiplication. Okay, so what is given here? 1, 1 minus 1, 1 into xy is equal to 2, 4. Then what is the value of x and y? Very simple it is. Okay, so just multiply, see what is that you are going to get. You are getting x plus y is equal to 2 and minus x plus y is equal to 4. Okay, so what is it? We are going to get, we can add the 2. So I am getting 2y is equal to 6. So from this, y is equal to 3 direct. Okay, but I have y is equal to 3, 2 options. So I have to make a choice now. So substitute. So if y is equal to 3, so x plus 3 is equal to 2, you are getting x is equal to 2 minus 3. So x is equal to minus 1. So which option satisfies? D option is going to satisfy. Yes, is that clear? Yes? Okay, come on. We go to the next question. Question number 23. So let's see what this question is going to tell us. A is equal to, yes, A is equal to, again we got a question from matrices. Okay, so matrices also is an important chapter with greater weightage. So A is equal to cos alpha sin alpha minus sin alpha cos alpha. What we have to find? A into A transpose. Okay, so A is cos alpha sin alpha minus sin alpha and cos alpha. Okay, so A transpose, so transpose A dash is equal to, transpose is rows and change, the columns are interchanged, cos alpha sin alpha minus sin alpha cos alpha. Okay, so I need to find what is A into A transpose. Okay, so therefore just check what will happen. Cos alpha into cos alpha is cos square alpha plus sin square alpha. So you're getting 1. Next, cos alpha minus sin alpha, that is minus cos alpha sin alpha plus cos alpha sin alpha, you are getting a 0. Next, second row with the first column, minus cos alpha sin alpha plus cos alpha sin alpha, this is 0. And we have here minus into minus plus. So sin square alpha plus cos square alpha is equal to 1. So what type of matrix you got here? What type of matrix? Very simple. What type of matrix? Matrix is nothing but the identity matrix. Hope this idea is also clear. Yes? Okay. So we move on to another question. Clear, right? Okay. We move on to the last question of this session. Come on. So we go to this and we find this question from Determinants chapter. So what is given here? If x, y and z belongs to R, okay, they are the real values. Then what is the value of the determinant? 5 to the power x, 5 to the power minus x the whole square. Look at those determinant. As we look into the question looks very tough. But believe me, just with one shot you will get this answer. What to do now? When you get such a difficult type of question, try to put some values for x. Put some values for x, okay? So it is like I always tell, try to throw a stone on the mango tree which is filled with, full of mangoes. Okay, if you are lucky, the mango will fall. So now here, what we will do, let us take x value is equal to 0 and check what happens with the determinant. So put x value is 0. So what is this now? 5 to the power 0 is 1 plus here also 1. So 1 plus 1, 2, 2 square you are getting 4. Okay, here what you are getting? 1 minus 1, you are getting a 0 and this one as it is. So what about here? So here you are getting 1 plus 1. Again you are getting 4, 0, again 1. Again you are getting here 4. So what is this now? Once again 0 and this is 1. What do you know the property of determinant? What do you know the property of determinant? If any row or column is having zeros, then what happens to your answer? The value of the determinant itself will vanish and that will become a 0. And that is your D option. Yes? So just observe such a difficult question just with one x, because x equal to 0. See, look at what happens to your determinant and this is 0. So hope you have understood what we have learned today, a few questions of this session. Yes? Okay? Yes. So I will be back soon with the next session of YouTube. Stay tuned till then. Thank you so much for joining.